I'm live. All right, thanks, Mr. Certainly. I'm live on Twitch. And let's see. Mark's on YouTube. Let's see if this other chat is working. So I had to rejigger the chats because YouTube changed the way that they work theirs. So I do have just camera. There we go. So we can see the Discord, we can see YouTube, and we can see Restream. Welcome to my life, juggling all the different chats. I can see Mr. Certainly live on Twitch from Twitch, and I can see Slow-Mo asking how do you communicate with them. I can see you. I don't know if you can hear me. Sorry I was a smidge late. I like to get started just before 2. But Phil challenged me to do an overview of low power in CircuitPython in under a minute, and so I gave it a couple shots before I started up here. Let me say some shout outs to folks in all my different chat windows. So, hi Mark, hi Charles, hi Dennis, hi Jim, hi Yasir. Mark has a beer. Charles Burnford says I'm live on YouTube. Marco says, hey Scott, how's it going everyone? Unexpected Maker, good morning. Thanks for waking up and hopping into the stream. Paul says it works great. And yeah, the notification works from David. So thank you all for joining. I've been getting lots of great feedback. So thank you so much to folks who have said that that this is, you're liking my deep dives, even though I feel like they're definitely deep. Yeah, Unexpected Maker spotted that I have ice in my cup, and that's because it's, I don't know, warmer here. I mean, we're at the, like, kind of in the middle of spring. We can just see. Oh yeah, you can't see my screen. Perfect. Yeah, the high is 77 today, which is Fahrenheit, of course. 82 is the high Saturday and Sunday, so it's gonna be a bit warm. This is great. This is basically like green bean and tomato weather, which is awesome. I wonder if I can just oh, don't spill the beer on my keyboard. Yeah, crazy nice day for Bruce as well. I wonder if I can sneak. I've got so many chats open. I want to see. Mr. Certainly says they're expecting snow in New Jersey and New York. That's pretty wild. Let's see. Let me switch screens. I'm going to try to like tuck some of these chats underneath the part of my screen that I stream with. So if I just bring my Discord over here and then I shrink it. Oh, it doesn't go anymore. I can move it, but that doesn't help me. Okay. Too many windows. How small does OBS get? How short does OBS get? Beware, I might go into Inception here. Yeah, you can see just the top, tippy top. Maybe if I shrink it just a bit more. Now I can't actually tell if it's on there. How does that look to everyone? I can see my audio, which is actually the more important bit. I can't see my video that well. So shout at me at the chat if need more screens. I've got just one wide. I have an ultra wide, which I love. I love it that there's no like bezels in the middle, which is great. Let me catch up on the YouTube chat. Oh, and I can see Restream. Yeah, Bruce says it's a warmish spring day north of Vancouver. Yeah, you're close to me. I'm in Seattle. David must be in Seattle too. Matt Lamb says, "Hey Scott, I've got one of those salad boards too. If you have a build you'd like someone to tinker with." And Jim is in New England, expecting snow. Johnny Bergdahl says hi. Whoa, Bruce says, "I'm watching on my 65-inch TV and typing on my laptop. I hope I look that good. I hope I look good that big." I'm actually in the works trying to get a better camera. Um, Dennis says, have you crazy thing plugged into your USB? Unplug. Unexpected maker knows why. Yeah, I saw that. Hi, Omar from Mexico. Thanks for watching. All right, should we get going? We got some exciting stuff to cover. For those of you who don't know, my name is Scott. Actually, let me do my screen just a bit before I officially do it. You know, I never edit it, but I feel like I should anyway. I saw Peter do it, and I think it's a good... So you get to see my logo. We'll do this. Hello, everyone. For those of you who don't know, my name is Scott, and I work for Adafruit on CircuitPython. CircuitPython, if you don't know, is a easy to use version of Python for microcontrollers, which are really small, inexpensive computers that typically are like tiny chips on a larger board. What I do every Friday at 2 p.m. Pacific is I go over... I do a deep dive into some of the work that I've been doing on CircuitPython. So this tends to be about 2 hours. That is as long as my like voice can kind of handle it. Yeah. Oh, Unexpected Maker points out if I edit it, I lose the chat in YouTube as well. True, but I've been trying to also include the chat on my stream, so that helps as well. Yeah. Hi, TG Techie. Okay, so these deep dives I'm doing every Friday, and what they've kind of turned out to be is I'm bringing up the ESP32-S2 for CircuitPython. This is a chip from Espressif. They have kind of two others that have been very prolific, the ESP8266 and the ESP32. Hi, Carlos Diaz. And the ESP32-S2 is their third chip that I know of. There might be some others that I'm not paying attention to, but the thing that we care about is that it's the first chip from Espressif that includes native USB. And that is awesome for CircuitPython because we use native USB. Greg says, "Love the Teardown shirt." Yeah, thanks, Greg. I enjoyed Teardown. Yeah, so native USB is really great because it allows you to do more than just serial over USB, which is what the other chips were able to do. And so in CircuitPython, we do mass storage. That's what makes it show up as a drive when you plug it in. And then we also can do CDC, so serial, like you would expect. And then also MIDI or HID, which is like mouse and keyboard. Hi, Joey. Welcome. I think I'm seeing all the chats. I've only got 3. I'm actually... let me know if you... I was thinking about trying to push everybody to Discord and have just one location. Although when I set up the overlay for Discord, it's a fixed size, which is kind of silly. The other ones are nice that you can scale how long they are or how tall they are. I'm glad I thought of that, though, that we're changing the way we're streaming to YouTube, so I knew that the like restream has been getting the YouTube comments and now it's no longer. So I'm glad I thought ahead and included a separate YouTube comment breakout there. Okay, so I've been doing these deep dives. They last about 2 hours because that's about as long as I can talk. And it gets hot in here, especially as I'm in the northern hemisphere, so we're like in the middle of spring, and then as the summer goes on, it's going to get even hotter. We'll see if I continue to do it kind of long term. But what I've committed to now is basically I want to do deep dives into the ESP32-S2 and kind of check in as I make progress with the port of CircuitPython to that chip. So that's the plan today. First, I want to show you how far I've gotten, and then I'll cover kind of how I got to where I am now from where we left off last Friday. This was the first week that I've really had kind of all week to work on it, which has been amazing. And you'll see that I've made a lot of progress, which is awesome. And if you saw Show and Tell either with Katney yesterday or with Phil and Lamore on Wednesday, you know kind of what has happened. But it's exciting. And then also I'll recap how I got there from where we were last week, basically going through the changes that I've made in GitHub between then and now. And then lastly, I want to make some more forward progress. And as I say in the description, trying to get digitalio working. So I do have a breadboard with an LED on here, and we'll see if we can't get to Blinky today. Although I really don't know if that'll happen or not. And yeah, so I have some stuff on the overhead that I might have to move out of the way because I was doing the low power thing. But let's see, what view should I do for this? I think we should just do here. So Discord's my highest priority chat. That's why that's the only one showing. I can still see the others just off screen. So let's just do a bit of, let me clean this off. Hey, thanks, Joey. That reminds me, actually, I should talk about supporting Adafruit. Thanks for the $2. Let me think. Distracted me with your kindness. Uh-oh. The overhead is not updating. It's showing the jewel scope, and the jewel scope is not on there anymore. I really don't care. Although, I mean, maybe we'll fuss with it later. That's annoying. Is that true for you all as well? You can only see... It looks like the overhead's not working. Maybe if I turn it off and back on again. It actually looks like it's frozen here as well. So I have a hover cam and I'm just going to restart it. Unexpected Maker says, oh, you have a jewel scope. Yeah. I really want one, but they're so expensive. Not too expensive for what they are, but yeah, lots of money. Yeah, I did. I like the jewel scope a lot. Matt has been supportive when I've crashed it. I crashed the Python software for it, but the hardware itself is not open, but the software is. I can switch back to I'm just restarting the hover cam to see if I can't get the overhead working, because I want to show off my setup. But yeah, this is the first time I've done low power, and using the jewel scope's been really nice about it. TG Techie, I have the Ultra 8 hover cam. And that looks like that is live, but it's kind of uncertain if... Oh, it does work. Okay. And you can see my hand. It's not frozen. Yay. All right, so some of these wires I don't need right now, but I had to get them out so that we could have them when we're trying to get to Blinky a little bit later. So the first thing I'm going to do is so there's two connections that we do to the Sala. So this is the Sala, and it has the rover on it. One thing I've done since we last talked is I renamed the board name for the Sala to be more descriptive, because they sell it both with the rover and with the room. And I believe the difference between the two is that the room doesn't have the external PS RAM, which is 4 megabytes, and will definitely... In CircuitPython, we're going to want to be able to have different build configurations, because one will have way more RAM than the other one will. So I've got my special USB. Yeah, ammeter I think is the right thing. It can tell you like the current and the voltage. And I have, where did I tuck it away? Let me show off a board I designed for it since I've got the overhead going. I actually made a custom faceplate for the Joule scope that, let me flip. Whoosh. So the way that the Joule scope works is that it basically has an input from one side and outputs on the other. And I made this custom faceplate that allows me to toggle the data lines off and on, which is pretty neat. It's similar to what my cable does, but I also have an LED for it, which makes it handy. Yeah, very cool. They have like open documentation for like the form factor for the for the faceplates. I actually designed a different faceplate for battery, but I've never actually tried it. Okay. I don't need that. I'm trying not to just throw it on the floor, but we'll see. Yes. Obviously, I'm a little scattered, but that's fine. Adafruit. Adafruit pays me. They're currently not shipping orders or not manufacturing stuff, although they're starting to ramp up a bit. They're doing PPE. So if you want to support us, find Adafruit projects on DigiKey. Give us you go ahead and buy a gift certificate. They don't expire, and you can use them kind of like a debit card. So when we do start shipping stuff, you can use that there. And then also, Adafruit IO is a great IoT solution for just storing your data and sharing dashboards. So if you want to support Adafruit, who pays me, please do that. And DigiKey is awesome as well. The other thing I wanted to say, the cat. As some of you know, I have a cat who loves to sleep in here with me. He's a white cat, so you can probably not see him. He's down there in the sun. That's all blown out. He's epileptic, so occasionally he does have seizures, and you'll hear him hiss. And what I'll do is I'll just mute the stream, and you'll be able to just watch me stand here. But I do like to stop and watch him because there are lots of cords and stuff, and if he moves around, he might get tangled up on it. So if that happens, just know that I'll be back, and he'll be fine, just as long as I watch him. And take a break, get a glass of ice water while that's going on. If it happens, we'll see. Probably not, but you never know. He just pieced out in the sun. I should have a cat cam too. Maybe actually, maybe that's what I'll do is once I can get this other camera going, that should be higher quality. Maybe I'll make this one cat cam, like focused on the sun area so you can actually see them. But they're white cats, both Spook and his sister Vin. Okay, so I think I got any other housekeeping that folks can think of that I need to talk about that I forgot. I'm only like 20 minutes in. Unexpected Maker is trying to convince me that the W in moreover is silent. And then says, even if it's not supposed to be, make it silent. What? You don't like moreover? Room? Johnny says, we do low power stuff, so I jumped on the Joule scope when I was on Kickstarter. Got the early bird price. Seems that is half price. Yeah, Invisible Kitty. Stealthy. Okay, so Sala. Now that hopefully the overhead's still working. This is the problem. I have a hot corner in the bottom left. I don't know if you notice. I have a hot corner in the bottom left that like moves all the windows apart so you can see them all. But my like scene controls are in the bottom left too. So I keep hitting it. Overhead. Okay, so we have a Sala. There's a USB port here, which is connected to the chip through a USB to serial converter. And this is great for debugging, and this is how we're currently loading code. And somebody did ask for a build, so I can cover that. I don't have any, but you can just snag my branch off GitHub and try it. So the first thing I'm going to do is I'm going to load or I'm gonna just connect there. So that's where power is coming from. And then let me spoil it a little bit. Jeff says, hi, first time live stream. Awesome. Thanks, Jeff. And I should definitely switch to this view. And sorry you can't see all the chats, but I had to make room. I just want to do, so I have a USB hub kind of off screen here, and so this other thing here is it's connected to the native USB on the ESP32-S2 rather than the serial converter. So I've got like a USB cable here that it's connected to, and I'm just going to plug that in. And see what happens. Maybe nothing. Oh no. Of course my demo doesn't work. So what I was thinking would happen is that we would get the CircuitPython drive, because I thought I got that working. Let's dive in and debug. So I have make flash screen tty.usb or slab. I don't know why it's not in my history. That should work. Jeff says if you mix the data wires, you damage the board. That I don't know. I've hopefully not done it. And then Emmett asks, what do you think about TT4? I think TT4 is really cool. The IMX RT chip that it has on it is really neat. One thing I'm going to do is I have this, I actually have a TT41 on my desk too, but I'm not allowed to show it to you. I have this cable that has a switch for data and charge. This is the one that you could get off Adafruit. And I'm actually just going to put that in between the two. I must have busted it. Oh, here we go. Ivan's in the chat and can answer your question. Whoa. Did I not set the... Ivan says, fun fact, if you mess up an ESP32-S2 board design, swapping D plus and D minus, you can fix that by burning one E fuse. There we go. So it sounds like you won't damage it, and you'll be able to reverse it, which is awesome. And welcome, and thank you. A huge shout out to Ivan in general, who's been really instrumental in getting me going. So what is the deal? Why is my slab not working? Maybe I have to give it the speed. This is kind of a quick thing I have to just flash the latest version and then connect to the serial. All right, so it looks like it's working there. I just have been adding a bunch of printf debugging because, you know, it works. And now if I hit data, we see USB connected. Oh, and it's prompting me, hey, yo, do you have a keyboard? I wonder if it has to do with the serial output being wrong or something. I'll have to try that. But we got USB, and if I pull this up, we have a CircuitPython drive. What? I think last time we did this, we couldn't get it to link. So in a week, we got it linking and working. So what I can do is, so for those of you who don't know CircuitPython, we can do screen to the USB modem that shows up. And that's not the right thing. So proof by, hi Jeremiah. Bruce says, yay. Yeah, I was thinking everybody should bring something to celebrate with. So we have a serial terminal here. And you can do 1+1. You can print hello. And that just works fine. And then if you're ever in the REPL, what you can do is you can do Control D, and that will get you back out of it. Just saying hi. We're hacking on some ESP32-S2 CircuitPython. Long live printf debugging, says Summersoft on Discord. Yeah. Printf debugging is the one way that works every way. Johnny's got a gin and tonic to celebrate, and Bruce has a latte. Good job, folks. Okay, so the demo's not done yet. So CircuitPy drive showed up, and I can double-click code.py, and it got me a second window. Jeremiah, don't make me ban you. Come on. Timed out. I don't know. Can you see that? I guess you can't see the YouTube chat anyway. Scooch this over. Alvaro says screen versus Python 3-M serial tools mini term raw filter colorize. I've never actually used that using PySerial instead, but I've used screen. Okay, so let me set this up. So the selling point of CircuitPython is that it shows up as a drive with a code.py file on it. And what you can do is you can say, hello, deep divers. And then all I'm going to do is hit Command S to save. And it reloads and shows the new code. All natively. Super quick. Fred Hayes says homemade Riesling. Ah, that's awesome. That's a great celebration. Ah, yeah, and we got a ta-da from Summersoft in Discord. Akshat says, what are we even doing in this? Yeah, I'm showing off CircuitPython on the ESP32-S2, which is a new chip from Espressif. And it's really interesting because it's a low-cost Wi-Fi chip. This is the board that's running all of that. And so the whole processing of the Python file is happening on the chip underneath this shield right here, which is neat. Those of you who have been watching my stream before kind of know that it's been a slog. It's been like a few weeks not being able to get a lot of work done on it. And now we're kind of like CircuitPython on the ESP32 is like close to being like ready, like foundationally ready. Unexpected Maker is asking Ivan if there's any word on the next IDF S2 update, particularly for the ADC support. I am not there yet, so take your time. Maybe we'll get Blinky going today. But first I want to, because we're deep divers and you've seen me struggle through linking and stuff, I actually do want to cover what I've done since then. So how I got over the hurdles that we were hitting. So I forget who it was. I can scroll up. Who was saying that they have a Sala they want to try this on? I know Mark knows about it. Yeah, so one thing I'll need to do is figure out why it didn't work when I wasn't connected to the serial terminal. Yeah, Bruce wants to try it. Nice. Yeah, I just ordered some more Salas from DigiKey as well. Should come maybe tomorrow. Oh, ADC support was merged in. Looks like. Maybe the forum is not up to date. My mom is texting me and distracting me. Okay, so this is the ESP32-S2 branch on my GitHub. And what I wanted to do is just take a look back at the commits that I've made And I want to try to do a comparison. So fixing stuff, adding pin definitions and almost links is where we left off last time. So I'm going to try to pull up a comparison. I'm clicking this button, which is going to copy this hash. And then I should be able to go back and hit compare. And this is going to be slow because it, by default, Unexpected Maker says hi to my mom. I'm not going to text her back right now. I'll say hi to her later for you. It is Mother's Day on Sunday, at least in the US here. So let me change this. This should make the comparison a lot smaller. Okay, so this is a GitHub comparison between where we left off on Friday, last Friday, and where we are checked in as in earlier today. I don't think I've changed anything. So one thing you can see is I printf debug a bunch. So the way that you do that is you include this ESP log and then provide a tag, which if we look back at the terminal, we can see the tag here is the part before the colon. Mark says, no testing for me tonight. I'm kind of lurking. That's all good. This is just the beginning. Okay, so you'll see that I've added just a lot of printf debugs. And there's no shame in that. It's the universal way of debugging stuff, I think. I've very rarely been in a situation where I can't use printing to figure out what's going on. So one thing we'll see is that I'm adding a bunch just to see where I'm ending up. And then I was also validating the stack allocation thing. Now, traditionally, in most CircuitPython boards, the memory range for both the heap and the stack are the same. For those of you who don't know, the stack is the memory space used for storing like local variables for function calls. So the stack kind of grows from one side and gets deeper and deeper and deeper as you've kind of like nested called more and more functions. And then the heap is kind of this free-for-all section for memory that's going to last separate from a stack. Now, with the ESP, the stack is managed by free RTOS. We talked weeks ago now about like one of the things that we're going to get to is like me having to learn a bit about free RTOS, and that's kind of like where this week has ended up. And so I've made some changes here to tell CircuitPython about the stack that FreeRTOS has given us for the main task here. So that's what this is. And you can see here that like MicroPython is also doing some stack validation to make sure that you've set aside like a maximum depth, and then you want to make sure that you don't go past that, because what happens then is you end up in your heap and you end up overwriting memory and things go bad. So it turned out, and we'll see this further down, but the way that you can kind of detect when that happens, when your stack has grown past kind of where you expected, is you can actually write like a known value to the bottom of the stack and expect it not to change at all. One of the funny bugs that I hit like yesterday or the day before was the fact that CircuitPython does that trick and FreeRTOS does that trick. So I was getting FreeRTOS stack exceptions because CircuitPython was writing into the same place with a different value, like a different canary value. So we were overwriting their canary, and they were complaining. So I thought that was really funny. And the fix that we'll see as I scroll down here is I actually just changed the CircuitPython canary to be the same one as the FreeRTOS one. Which is kind of interesting. Okay. So more just logging. Logging is really handy to just figure out like when things are going bad. What is the problem, or like where the problem occurs. So lots of logs, lots of logs. And I'm doing this early log. So this W here is like the level of the log. So W is for warning. You could get like, it's like error, warning, info, debug, everything or something. Like there's a number of grades and it's changing the color and stuff. But I'm just using W for everything. And the early thing is I think that it makes sure and spits it out right away. David says, how does the stack checking interact with interrupt handlers that push values on the stack? If the interrupt handlers stacks are too large as well, it overwrite the canary. Like once you go back or once you have a chance to check that the canary is the same value, you'll if CircuitPython finds it, you'll get the recursion depth limit error. But if FreeRTOS finds it, like you'll get a FreeRTOS error instead, which we don't handle in CircuitPython, or like don't bubble that up in CircuitPython yet. But maybe the way that we would do that is we would, I don't know. I don't know much about FreeRTOS, but like we theoretically, if FreeRTOS found it, we could do the same thing of like raise an exception and say, like, oh, you ran out of stack space. So this is the change that I made here to set our canary to the same canary as FreeRTOS. And then there's a couple, we were having linking problems as of last Friday. So one of the fixes that I found was needing this -F no RTTI. And the person that gave me the credit for that is Jeff Epler suggested using a trace symbol linker flag that allowed me to trace for the particular symbol that I was having trouble linking in. I forget what it was, but basically what I noticed is that the places that the libc it was trying to pull from was I compared the two, and between the Ninja build and CMake build and the CircuitPython build, and the no RTTI was one of the things that was missing. So I flipped that. All right. I'm gonna put this user in timeout too. Huh. Must be getting more YouTube watches today. And it can't show up on the screen anyway, so I'm okay with that. So that was one of the linking issues that we found. One of the other issues that I just fixed this one yesterday. Correct. So yeah, Unexpected Maker says CircuitPython doesn't support interrupts, does it? Yes and well, no, not for users. We do use interrupts internally for a lot of stuff, but we don't expose them to the users. Largely because I think concurrency is really hard to understand and to program for. No, we haven't added interrupt support. There's a big long issue about the best way to do it if you have opinions, but it's a hard problem. Okay, so how are we doing? 20 minutes? I think we can get this done in 20 minutes and then we can start hacking. So when I was doing make flash, the flash command takes a bootloader.bin, and that wasn't working. So what I had to get that working, it wasn't working from make, but it was working from my path. And so what I realized is that I had to give the full path to the IDF as my IDF path, and then it fixed it. One thing I had talked about, I think last time or the time before, was this idea that it would be nice for boards to be able to override parts of the kconfig for the ESP IDF. So kconfig is a system that allows you to like pull up a menu and like go through the menu and select different things. I've showed it previous weeks, but I was talking with Ivan about it, and it was good to. I can't actually see the Discord. Not much chat there. What I wanted to do is switch it so that the way that the CMake IDF stuff processes the kconfig is it spits out the final version somewhere. And so this change here is me changing it so that the final kconfig is put back into the build directory. And it's a combination of the kconfig defaults, which are just in the like port level directory, and then also the board specific SDK config. So that's what that is. And I was surprised I actually got it working. So let me scroll down and just show, since I'm talking about the menu config, where did it go? Maybe I didn't. Oh, no, it's right below it. Or no, it's right here. So this is the menu config target in make. And what we do is we run menu config from the IDF, and then we actually can just take a diff and write it back to the board version. And it turns out it actually seems to work, which is pretty neat. I was a little worried because it doesn't necessarily have a way to unset a value, but it looks like it's working so far. These two targets here, partition table and bootloader bin, I need for the flash. And since Ivan's here, I have a question for you. Flash flags, I just factored this out because it's used both by the flash command and some other command. DFU isn't used, so I removed that. I made it not board specific because I renamed it and found that didn't work. Elf to image, I just made the flash flags. Right. Okay. So Ivan, I have a question for you. Here's our flash command, and we're actually taking 3 build artifacts. We're taking bootloader.bin, we're taking partition table.bin, and we're taking firmware.bin. Now the question is we really should only distribute one file for CircuitPython. Is it okay that we rely on a partition table and a second stage bootloader already existing? Or should we pack those into the file that people flash? Or what? It's an outstanding question. We don't have to figure it out today. Like, we'd like to support UF2, and so maybe the UF2 would have the partition and the bootloader, and then like the CircuitPython stuff would just happen after that. It's an interesting question. And if you have thoughts about how, like, what one file we should distribute as CircuitPython, and whether that'll vary per board or per, like, what things, like, if somebody's used Arduino on it already, like, what parts should we share and what parts shouldn't we share? Okay, let's keep going. So here I'm including FreeRTOS task stuff, and I've found that I can't just include task, I actually have to include this as well before it, which is a little wonky. Ideally, they should just include the stuff they use, but for some reason that's not the case. This was a bug I had where background tasks would run once and then not run again. So I had to remove that. I removed USB background, which I might actually want to add back. But we'll get to that. And then I have to call this vtask delay. Now, FreeRTOS is a real-time operating system, which means it's trying to keep track of kind of multiple things that want to happen and which things need to happen when. And by default, the ESP IDF has what is called an idle task. And this is kind of like really low priority stuff, but like housekeeping stuff. And there's a watchdog timer, which basically makes sure that like that task runs every so often. And so this is kind of our version of that. Background tasks is the CircuitPython version of that. And so we just need to take a chance to delay for 1 tick, which by default is like 10 milliseconds, which is a really long time, and give the idle task a chance to run, so that it can reset its watchdog and not complain to us. Okay, Ivan says you can create a single binary file, essentially a flash image. The file would contain the bootloader partition table and the app at the appropriate offsets with FF in between. Yeah, that would make sense. I was happy with how the partition table stuff went. I'll get to that later. You can create it with 4 DDU commands. Can send you an example on Discord. Yeah. Yeah, well, we can do that. I'd like to do UF2 at the same time, so we'll have to figure that out as well. So if you so going back to this vtask delay, if you try it on your Sala board and you try to do performance metrics about like, is this faster or slower than like the Teensy or the CMD51, this is going to slow it down a lot because it's waiting 1 tick, and that's a long time. But we have to kind of say like, we're not doing anything for 1 tick so that the real-time operating system takes that chance for the idle handler. There's optimizations galore that we can do in this first version, but it's not important. It works well enough to... The challenge with the very first PR of a port is that you need to get kind of the whole workflow going and get everything set up so that like other people can work and not kind of propagate badness as well. So like, for example, one thing to care about a lot is making sure that the CI is up so that when people add new boards, wink, wink, unexpected maker, wink, wink, that we verify that the builds work and are correctly set up. And that the things that we copy from board to board to board are kind of minimal in what they are, so that there's not like a huge amount of stuff that are copying over. So this first version is not about performance optimization. It's not about power optimization. It's not about memory optimization. It's about getting that workflow going so that everybody or multiple people can work on the separate pieces kind of concurrently on a particular port. All right. This shows that I've renamed the Sala to the Espresso Sala 1 Rover. I'll try not to say the W. And Ivan pointed me to some DD commands to create just 1 image, which would be really handy. Okay, so I've specified the board name better, and I've deleted some of this previous Flash stuff that I commented out. I'm going to delete it. And then I got a new USB VID, which is Adafruit one, and the PID for this board, along with the USB devices we want to support. And I introduced flash mode, frequency, and size on a per board basis, and that's used in the ESP tool commands. When we flash, it's not actually used after that, which I think we'll get to. Here's the SDK config stuff. This one's just empty because it's the only one I've tried, but we may see diffs here eventually. I've updated the ESP IDF. The only thing I had to fix was there was 2 undefined warnings that I fixed, which should get back on the IDF at some point. Another thing around the stack that I had to do is that when CircuitPython and MicroPython are figuring out which Python variables are still living, they need to, they're very, what's the right word? They're very broad in what they consider to be alive still. So yes, yielding might be what I really want to do. Mark says task yield is probably what I want. Actually, you know what I can do? I can switch to... You don't need to see this. That's boring now. Let me switch here, and now we can see some of the other chats. I tried to use vtask delay 0 and it didn't work. It wasn't actually calling the idle task handler, I don't think. Or at least the watchdog was complaining still. Bruce is saying yes. Not sure to what. So what this does is when we're garbage collecting, we've got to figure out what's still being referenced. And so the way that we do that with the stack is we literally just look through the whole stack. Anything to allow the scheduler to run. Yeah. Yeah, but the scheduler needs to run and it has to choose the idle task. Because the idle task actually needs to run. Okay, so more stack stuff. I had to make sure that CircuitPython knew the range to look when it was garbage collecting. I had this bug where the range was being flipped. So the low bounds was actually a higher number than the bottom bounds. And like once I started garbage collecting, I just like perpetually did because the bounds were wrong. So that was bad. And the watchdog says like, oh, you're hung basically. And so getting my stack bounds was important for that. Okay, let's talk partitions. So we saw the CircuitPy drive show up. How do we figure out where that is? Okay, so task yield will allow anything that wants to run. So as long as the idle task wants to run, it should. I'll have to take a look at that later, but is task yield actually available in FreeRTOS 8, which is what the IDF actually uses? It's not using the newest version of FreeRTOS. So that might be a problem. Ivan says another option is that you can disable the task watchdog if you aren't deleting tasks dynamically and if you don't care about power consumption. It is fine to not run the idle tasks. Yeah, I thought about that, but I saw some documentation that was like, it's important that this is called that does housekeeping, and so I decided not to do that. And I do care about power consumption, but I don't know if it might have been set up already, but sleep should actually call delay for a longer amount of time. So background tasks is not important when it comes to power consumption because that's something that happens as Python code is properly executing. Whereas sleep is like, oh, I'm actually not going to do anything for a little while. Yeah, and if folks have questions, we're definitely getting in the deeper into things. So if you have questions and want me to like take a step back and talk about the principles of something, please just drop a note in the comments and I'll circle back. Forgot that the ESP32-S2 is single core. Yeah. Okay, so file system wise, what I have it set up to do is the partition table now must, well, I need to handle this gracefully, but basically you can just give it a data partition with the fat type, and that is what's used for the CircuitPython drive, which is super neat. It's not hard-coded through any CircuitPython mechanics or anything. It's just done that way. And how's that done? Well, I saw this cool API from the Espressif IDF called partition, which allows you to introspect the partition table that's burned onto the device. So when we initialize we call this internal flash because there's a lot of mechanics that use it. And we basically don't have to do the like SPI protocol level. So we just call this internal flash, and we looked at the partition table for the first data type with that is a fat partition, and then we just use that. And if that area is not actually a fat file system, we'll format it when CircuitPython starts up. Okay, Ivan says running the idle task is important to let the tickless idle power saving mechanism to work, but it would likely not be among the first things for CircuitPython to support. Okay, so do you need to run the idle task when you're not power saving? Or is it okay that I only run the idle task when I sleep? Because it's in here. Since we're talking about that, let me skip ahead. Oh, Alvaro's got a good question. Okay, so for sleeping, so if you're calling from CircuitPython time.sleep, here's the way I have it working right now, is I found this vtask delay until, which should yield and cause it to run the idle task. And the reason I have to use that is the API that I have right now, it's like a two-phase process where one call of the sleep stuff says interrupt me after this amount of time from now, which when I'm using an RTC, I would actually set the timer right then and there, and then I have this other sleep until interrupt. I have this print right at the start, so this is how I'm hooking into FreeRTOS. Okay, there's a couple good questions that I'll answer after this. So app main is what the IDF calls, and I wrap it with a hello from CircuitPython at the very start, and then just calling main, which is CircuitPython's main. Ivan says, when not power saving, idle task is only needed for deleting the task TCBs and stacks. Okay, yeah. I don't think we're going to need dynamic tasks, so we wouldn't need that. Okay, Alvaro's got two good questions, and you should be able to see them. The first one is, will WebREPL make a comeback for CircuitPython? And I don't have any love for the WebREPL, and I'll tell you why. It's because I think it's really hard to discover the IP address of the device. So I would say no. I don't. And the other challenge is that having something live longer than the VM is quite tricky, and means that it needs to be special cased more. So my thought has been that I will treat the Wi-Fi kind of as like only living for the lifetime of your CircuitPython script. And the reason to do that is that that's a model that matches the model for if you have an external network connection, like if you have like IP over LoRa, is that possible? But like LTE or an external Wi-Fi chip where it really does only live for the VM time. So WebREPL is really not a focus of mine. If somebody added it, I would merge it. I would like do the PR review and do it, but I don't think it's that interesting. I don't think it's that useful. And then Alvaro also asks, for deep sleep, how is Adafruit thinking about power management for the board? Something like Unexpected Maker's Feather S. We haven't designed our feathers yet. And I wouldn't be surprised if we took inspiration from the way Unexpected Maker was doing it. One thing that has gotten the power treatment is the blue fruit. And one thing that Lamore did on here was like add a high side power switch to actually turn all the neopixels off. And then also for the on LED, it's like a low current LED as well, which is, I think, similar to what, maybe not to the same degree, but similar to what Unexpected Maker has done on the S2. Generally, it's not been a super important feature for us, but we are starting to get into being a bit lower power, especially with the NRFs and like sensors and stuff. So, and then in terms of APIs for low power, what we have right now is super basic, and it's basically if you call time.sleep, we'll do as deep a sleep as we can that preserves where we are in the Python program, which is not that deep because we're like keeping memory, we're keeping the CPU powered so that we know where we are. Like the program counter has to stay the same, and then we're also keeping all RAM as well. The other way that I want to do it is we have that now. A next step is to add the ability of like sleep until something happens, sleep until a pin changes or something like that. So that would get us to the point where you're no longer just sleeping based on time, which is cool. It's great for like, oh, I want to shut the screen off and like go into sleep state until somebody presses a button. And then further from that, I want to make it so that you can set those things of like wake me up on these alarms, but basically exit your CircuitPython program, and that will cause you to like go to a deep sleep where we don't care about the program counter, we don't care about the RAM, and like when we wake up from that, we basically start from the beginning again. So that's kind of the two APIs I've had in mind for lower power stuff. That may not happen anytime soon because I'm focused on bringing up like all of the more core stuff on the board, but the foundation's there. And I want to make sure that all our timekeeping stuff in this port is also conducive to doing that as well. Ivan asked, by the way, can CircuitPython run on a dev board being used as a kernel for Jupyter notebooks? Yes. There's at least one kernel for it, maybe more. I've not used them myself. Alvaro, if you want to ping Ivan on the live broadcast chat on Discord, you can post links there as well. I can post links to YouTube, but Discord's great. Discord doesn't disappear when the stream is done. So if you're not on Discord, I think there's a link on the stream. I think this way, right here. And you can actually see how many people are online if I'm not mistaken, but it's like postage stamp size on my screen right now. We're there all week. So if you want to like level up and engage with CircuitPython development more, please drop in our Discord and do that. Okay, I skipped over some things and it's 3 o'clock, so I want to get through this a bit quicker. But I also wanted to kind of highlight my approach with this, as I was talking about earlier, is to really just flesh out and get the bare bones going and not try to get hung up on optimizing too much. And one place I'm doing that is in this Flash work. So the API that the ESP IDF gives us is operating on writing and erasing at 4K blocks, whereas USB is always speaking like 512 byte blocks for like what gets written to the file system and stuff. So I just added this super simple, like always have 4K cache, and then if as you write a block, if you're switching between the block that you have in the cache and the current one, you just read it into the cache. And then for every block in that sector, I hope this code's right. It's not been reviewed, but it seems to be working. You copy it from the source block into the cache. And then you erase, and then you write. So it's okay to erase because you've got it in memory and then you write it out. But this is inefficient because it writes, if write blocks is called for like every 512 byte block, you're potentially like reading, erasing, and writing way more than you actually need to. So there's more code in like the external Flash CircuitPython code that is a bit smarter about sharing that cache and like creating it when we need it. So that, like if you've never plugged in on USB, like that 4K is not spent. But for now, this is the simplest way to just get it working. So kind of like the lower power work and this ESP32-S2 initial PR will be, it's like everything's a little bit wonky, but it should work. And then it can all kind of like be iterated on independently. So like one person could make this much smarter about how it does caching. Another person could make the like delay stuff smarter so that we're not spending a tick in the background task and stuff. Like somebody could focus on performance. Okay. Yeah, Alvaro says Tony had some code where he connected from the PC to the board itself to test things. Not sure that was with CircuitPython. Tony did a lot of Vermata kind of prior to MicroPython being a thing, which was like Python running on your host controlling the board. Okay, let's keep going. The other thing that needs to happen, so I got CircuitPy drive showing up, but I didn't get the auto reload working because the auto reload is on like a delay timer. Um, yeah, Ivan says, by the way, FAT tends to kill NOR flash pretty quickly because of the allocation table gets read and erased a lot. There's a wear leveling library which transparently spreads the erase cycles over the flash. Yes. This is silly because this is something I've always intended on doing for CircuitPython in general, but we actually haven't had too many issues about doing the wear leveling. But yeah, I'd be curious to try it. Yeah, I can send you the link. DCD asked for a link to the code I'm showing. It's in my if you just do tannewt/CircuitPython on GitHub, it's in the ESP32-S2 branch on there. It's all open source. It's great. Okay, so I had to create this timer. This is a higher resolution timer because for some things that CircuitPython does, it needs to be called every millisecond or so. So with the lower power stuff, I made it 1024 ticks per second, which is really like mathematically nice for a base 2 thing. I got distracted because that's not what I'm talking about. That's stack stuff. But yeah, so now I have the ability to turn on that like call supervisor tick every 1,024th of a second or something. And I'm just using the high res timer from ESP-IDF, and it was very straightforward and worked really well. I talked about the sleep stuff. This is more stack stuff, figuring out where the stack is from FreeRTOS. Okay, Alvaro says no. It was CircuitPython on the ESP8266. Yeah, we've had a Jupyter kernel forever. I've not used it, so I can't vouch for it. So if you want to maintain it, that would be awesome. Okay, what else do we have here? USB stack stuff. So we are using a separate task for TinyUSB. That's what I'm creating here, and I just statically allocated the stack. I just copied this from a TinyUSB example. And so that's what it's calling TUD task, and it's calling CDC write. So it's more stack stuff. I think we're about there. More debugging. So before I actually create a PR, I'll go in and remove all these logs because I actually do slow things down too. Okay, the last change I want to talk about is just this briefly. So I have the window open because it gets hot in here. So sorry for the noise. I just had to. I discovered that I couldn't call TUD task from the main CircuitPython task because I also have this other USB task going now. So I just reused the configuration value for TinyUSB, saying like only if OS is none do we call TUD task. TUD being tiny USB device. It's short for. Okay. That's getting everybody caught up. Any questions? I fielded a couple as we go along. So the hope is that once this PR is in, more than me will be able to work on it. So if you're curious of diving into CircuitPython C code, we'd love more help. And testing. Testing is great too. That's the other thing I think I need to do before the PR is I actually need to get like all the different board builds running and stuff. Because we have it so that you can just go to like our S3. I don't know what that is. If you go to circuitpython.org/downloads, you'll get like all the boards that we support. So you'll start seeing the ESP32-S2 stuff on here. And then you can click, and if it's in a stable release, you'll get a box. If it's an unstable release, you'll get a box. And then there's always this absolute newest for browsing S3. And so I'd like to get this download working from the get-go, kind of for the ESP32-S2 stuff. Okay. let's see. Let's switch gears into Blinky. So we've got our debug output that I'm going to leave in because it's handy. And let's go back to screen. And let's just see what we can do. Can we do import board? No. Okay, that's where we'll start. So we talked about this, I think, last week when we did the pin definitions. Board is the mapping between microcontrollers' names and the board's names for pins. The other thing we can see is if we can import microcontroller. We can. So let's print dir microcontroller. Alvaro asks, do you use CC cache as part of the build process? No, we do not. The only kind of trickery we play is because we build like 11 different translations, we build it once and then we only change the translation stuff, which causes it to do like a very short compile and then relink everything. But we don't use CC cache. It's not that large. But yeah, and it's also not our CPU time. So this looks okay, and let's just see what pin has. Heyo, that looks good. So we're getting different pin objects. And Alvaro, Summersoft says, I briefly looked into CC cache when we were still on Travis. I'd really like to get off make. I think Ninja could speed things up too. Oh, and we're still printing the dir. I just want to show you what this pin looks like, a pin object looks like. And I guess what we should also try. So board was not available, but we could try doing digitalio. And it's not available either. So we have to kind of a fork of the road. We could do one of two things. We can try to get board working, which should be really easy, or we can try to get digitalio working directly with the pin from microcontroller pin. I think I want to just take a stab at board because it should be really easy to get going. So I'm going to Control AK to kill that, and I'm going to eject drive because I'm trying to be nice to it, and then I'm gonna flip here to charge. So my data lines are now disconnected, and I think that there is, okay, here we go. I'll leave that window open too. So I think it's gonna be as simple as just enabling it in npconfig port.make. So there's this big long list of stuff that we have turned off. The idea right now is that like everything is turned off and we'll turn it on as we go and as we implement it. So let's just do board 1, go back here and do Control AK and just see if we can't build it. And we can't. There's no rule to make target common hal board init C. Okay, so that probably means that the file's just not there. The make file, it's kind of misleading to say that there's no rule because it's mainly made up of, what do they call them? Matching rules? Fake rules, basically, where you like give it a pattern and see, and it will kind of like automatically create a rule for it if it matches a particular pattern. So we inherited from the FOMU port, and the FOMU port doesn't have board, which I'm kind of surprised by, but it's also very early. So I'm just gonna go in here, and I think it's probably just empty. Yeah. But let's just add it anyway. We leave some empty files like this just because we want kind of a standard file system structure. And I added IO, which is not right. We also add IO to basically everything to make it unique. should be able to paste. This is the dunder. It's a Python thing. Is if you have 2 underscores before and 2 underscores after, they call it dunder for double under. And it's a standard pattern for like private stuff that people shouldn't use. Now that we have that file, it should work. Maybe. As long as we don't have any typos or anything. Things are happening. It's just not telling us. Oh. QString undeclared. So this can happen if you're including a file that you didn't before and it didn't detect that it needs to rerun the QString stuff. So QStrings are basically collected throughout the whole build and then sucked together. At that point, we also do collect all the strings to translate as well. And then QStrings are replaced by an index instead of the string itself to just make it a bit smaller. Deshipu corrects me. 2 underscores at the start is for private. 2 underscores before and after is for magic methods, right? Whereas magic methods are like methods that the CircuitPython that Python itself uses for magic things. Like if you use brackets, like that calls a dunder method, for example. Okay, so we're gonna rerun the QString stuff. It's actually running the CMake IDF stuff first. And I don't think I could do it in parallel yet either. Carlos on LinkedIn says, very good presentation. Thank you. Thanks, Carlos. Kojima Starship says hello from Twitter, Periscope. Hopefully it wasn't too long ago they said that, but it might have been. I've been bad about watching the restream. Just keep compiling. That's another thing we can optimize later. Interesting. Let's take a look at this. We're unable to build UART. We don't have UART on, but I have a feeling this might be because we defined, did we define our default UART bus? Yeah, we defined these 2 things. So let's turn that off. And that should mean that that UART code is not used. Yeah, you folks have more questions? I honestly expected a bit more excitement. Oh, nice. And Ivan's updated the ESP IDF forum post info. Thanks, Ivan. You've been super helpful. Building, building, building. I'd love to switch CircuitPython from Make to Ninja, because then I can call the Ninja rules for the IDF directly, and we could do more concurrency, which would be neat. Building the bootloader. Uploading. Awesome. So we built, and we should have access to board now. So we're started up, and let me flip the switch. You should see USB connected. we should see it show up. We can see the flash reads happening. And let's connect to the serial again. And let's see if we can do import board. We can, and then we can do the same thing. So dir shows you all of the attributes on an object. And we can see that we have the names that we did last week. So all of the stuff we did. Oh, DCD forgot to check out the ESP32-S2 branch. Yes, my master branch is useless. Generally, you don't want to use, like, for your personal work, you don't ever want to use a master branch. You want, I tend to name them based on what I'm working on. Okay, so that works. And now, actually, let's leave that. We want to make digital I/O work. We've got just under 40 minutes, although I'm feeling pretty good. So we're going to do the same process. We're going to turn digital I/O on. It will probably do nothing, or we'll have to delete stuff out of it, and then we'll add the implementation stuff. So let's go to npconfig port and add CircuitPy. I don't see it. Digital I/O. So full build here is like you want just everything on, but right now we're manually turning things on. We'll be able to do bitbang I/O after we do digital I/O because it depends. One depends on the other. So now we're getting digital I/O, and let's just take a peek at, actually, you know, first let me. Can see a bit more. Trying not to snoop on the neighbors as they're talking. All right, let's see what's in digital I/O here. Nothing in init, and let's just add this here to. Actually, I don't think we need Lucian's. And okay, so we have constructs, and okay, so this is all the FOMO stuff that we still don't want. The question is, should I try to get building, or should I just go straight to trying to implement it? I think we should be diligent about it. So this is, I think we talked about a few weeks ago, we talked about how CircuitPython was structured, where we have shared bindings, which is the layer between Python and C, and then we have the layer that's below that, which is Common How. So we're firmly in the camp of Common How right now. Alvaro says, I'm waiting on the edge of my seat for a blink. I know, right? Okay, let's keep going. Let's just comment this stuff out for now. I want to get it to compile just because it's good practice. And we'll notice that like the stuff that we don't need here, we can delete. So I'm going to do a clean just like I did before. Well, let me be good about. Ty says OMG and Taiwo says cool. Thanks for watching. Okay, switching to charge mode. And if you want to abuse it, you don't have to do that, but it's always nice to. And I'm cleaning again because I changed the. Ty says, I wonder if he charge code. Do you mean change code? I am changing the code. So I do have my, you can't see my overhead. One thing I need to know, and you all would know, is which side of the LED is positive. Is it the long leg or the negative or the short leg? I don't do it enough to know. So we'll need to know that before I can actually plug it in. Control reaches end of non-void function. Get value. Which one do we want to return by default? Get value. Return true. Yeah, I guess I was assuming we were going to do output first, but we could do input. Input. We'll need to do input as well. I forgot there was ice in my glass. Thrilling deep dives with me every week. UPS is here. I don't think I'm getting anything today, though. Ah, thank you, Eric. Long leg goes to voltage, short leg goes to ground. Perfect. I think that's how I had it. I've got a resistor too. I guess we can test it. And okay, I'm just like snooping on the neighbors today. Everybody's out chatting. Okay, so it compiled, which is great. And we can I'll just flip it and show that nothing happens. It should work. It should not error out, but it won't work. So if we're writing a for loop, we're just going to do while true. I guess we have to initialize it. So D equals digitalio dot digital in out. Digital in out. What pin do we want to use? Board dot, I don't know, 34. IO 34 D dot switch to output. Or we could do direction too. Digital IO direction. It starts as input. And then we can do D dot value equals true. Sleep 1. I think sleep works. Did we test sleep? Oh, we have to import time. It should work. I did that already. Oh, frame rate goes way down when compiling. Yeah, I'm all on the same box. On my yeah, sorry about that. Hopefully it won't hang. If it hangs, please let me know. I guess I can see it here. All right, let's see what happens. Since we actually don't have anything hooked up. Looks like sleep's working. Yanni says it's getting there. Ty Lee says, I wish I could do that. You can. You can learn how to code. Go to learn.adafruit.com for lots of resources. Unexpected Maker says, I'm still having to manually flash run the build folder. Are you trying CircuitPython? Is that what you're trying? Or are you talking about other stuff? Okay. Summersoft helped with what is plus is longer, according to Google as well. Buck asks, what computer language is that? So this here is Python. Python running on a microcontroller, which is a teeny tiny computer. If I switch to the overhead like this, I think this is where we're going to want to be. We can see my red LED. So Python is running on the chip underneath this metal bit right there. And then this computer language This language here is C. So CircuitPython and MicroPython are implemented in C under the Python hood. Orlando asks, what's the info for the weekly Monday CircuitPython meetings? And apologies for cross-posting. I forgot you're streaming now. No worries. If you want to know about the community CircuitPython meeting, it's 11 a.m. Pacific on Mondays every week. We do have a U.S. holiday coming up in a few Mondays, so we'll probably bump it to like Tuesday. There's a calendar for that, so check out the calendar. Everyone's welcome to join on our Discord. You go to the URL adafru.it/discord. And let us know you want to be in the CircuitPythonistas group to get notified about the meeting. And we just hop to the CircuitPython voice channel and record it and talk there for, it's been about an hour and a half every time, because we give everybody a chance to talk about what they're doing, which is great. It's been really good, and we started it in 2017, which is just mind-blowing to me. Donald is asking on Periscope, what is the chip you used for the CPU on the board? This is the ESP32-S2, which is an espressive chip. It's got built-in Wi-Fi, although we don't have the Wi-Fi working yet. But yeah, it's an ESP32-S2. Okay, our on and off is working, timing is working, so I'm going to shut it off again, and let's take a stab at implementing it. We got 28 minutes-ish. I don't have a hard stop, so if we get close, I'll keep going. Oh, I was going to switch. My USB gets really unhappy if I leave the data connected. Yeah, Orlando, you say you put it on your calendar. That would be awesome to have you there. And let me just point out that we actually have a calendar that Jeff did already. So this is the repo for all of our meeting notes. So you can just look by year. You can see our first meeting was September 18th, 2017. And we could even look, I guess we didn't take notes at that point, but we have a YouTube video. I don't know when we started taking notes, but I don't. Yeah, pretty wild. November. So if you go to here, there's an iCal in here and a Python file to generate it. So you can just copy this and subscribe to that in your calendar. So I'll just drop that in the Discord. And that way it'll stay up to date when we change it. Cool. I'm caught up on questions. Let's pull up I was looking at the I2C drivers, I think last time, right? Let's take a look at the GPIO driver from Espressive. Stuposolify says, got really into Adafruit IO today. Surprised how easy it is to send and read from the ESP32. Awesome, that's great. There's also an RTC GPIO support, which is available in ultra low power, which we're not going to support right now. Okay, interesting. So for our modes pull up, pull down, and interrupt type, I assume that's what it is. We're going to want to call this GPIO config. And then there's also this pin reset, which puts it in its default state. But the default state is connected to the GPIO function. This is the first time I looked at this, so welcome to my life. Like all deep dives. Some things I'm thinking about are, one thing CircuitPython does is it makes sure that you're only using a pin for one thing. And so I think what we'll want to check is, like, by default, if the pins come up with the IO mux connected to the GPIO with everything pulled off, like this is going to be the state that we call free. And then we'll have any other state, whether the IO mux is connected to like I2C or whether GPIO has input or output enabled will mean that it's in use, and we'll raise an exception if somebody tries to use it. Yay for pre-preparing. Yeah, I mean, this is a deep dive. I don't sugarcoat it. Interrupts we don't do. So this is pretty nice. Set level, like that matches. I guess this is good. We kind of scrolled through this file already to know what we have to implement. So it should be relatively straightforward for us to just call set level and our set level and get level and our get level. And wow, direction. It's almost like we're doing the same thing with the same names. Set pull mode. Wake up we're not going to deal with right now. We're not going to deal with ISRs, which is interrupt service routine. We're not going to do that. Pulls we could do. Pull up, pull down. And it is interesting that if we're doing this properly, we're going to want to make sure that that we argument check it. Although we get some guarantees that the pin is valid because we've like defined a fixed set that we know to be valid. So you can't just pass anything in. Is there a way to get is there a way to get the IOMux state as well? I mean, we don't have to do the pin freeing and stuff right now. It won't get us to Blinky, but we'll have to do it eventually. Yeah, it's too possible if I says, I still get confused with pin referencing on the ESP devices. Some listings use GPIO number, other use numbers referring to digital input number. Yeah, I actually prefer the GPIO numbering, but we've in CircuitPython inherited a lot of the D number, A number numbering that you get from Arduino, because like Arduino's roots are in chips that could either do analog or digital, but not both, I guess, or like at least that like only certain pins could do analog. But in a lot of the cases for CircuitPython, that's not actually true. And I think that people actually get confused that like, oh, I can't do normal digital stuff on an A pin because it's analog, where that's not necessarily true. So I prefer the just GPIO number. And asks, Stu possible if I says, can the deep sleep function be used in CircuitPython? No. No, but maybe in the future we'll add support for it. Not anytime soon though. Right. And so Summersoft on Discord reminds me that our CircuitPython policy is that in board dot something, we actually want to make sure and match the silk screen, the labels that are on the board itself, because those are the names you can actually see. Deshipu says analog pins can do digital except 2 pins on the Pro Mini. Yeah, that makes sense. Okay, let's keep scrolling down and see what all of our options are. Pin drive stuff, we tend to just set our pin drive strength to high, but we don't have to do that initially. Hold function is a deep sleep thing. Ivan says, I think you won't be using IOMux in CircuitPython. It is only needed for high-speed I/O like SPI. So suggest not to care about it for now. The reason that I care about IOMux is because I want to know if something is using a pin or not. So I want to know if like a high-speed I/O is connected to a pin, an output pin. I don't need to use it now, but before I check it, before this is done, then that's the case. Right. Ivan says most peripherals like I2C, your PWM and SPI can be routed through the GPIO matrix. Right. So the question that CircuitPython is asking is just like, is the pin in its default state, which means it's free, and we need to know whether it's connected to something like I2C or SPI in order to know that. All right, hold we don't need. Deep sleep hold we don't need. Oh, here we go. Set the pad input to a peripheral signal through the I/O mux. Input. Okay, and set it to an output. But we can't get the state of it here, it turns out. RTC GPIO we don't care about right now. That's for lower power I/O. We're not going to deal with that. The CPU asks, but are they slower than? They are slower than, though. I don't think they're slower if they're routed through the GPIO matrix. And he'll give a pointer on how to check I/O mux and GPIO later. Cool. Oh, is there two different matrices? Is that what's confusing me? There's one through I/O mux and there's another through the GPIO. That'd be cool. Either way, it means that you can route like most everything to every other pin, which is neat. Okay, enough gabbing. Okay, let's just do set level. Right? We want to see Blinky in the next 19 minutes. We gotta focus. Focus on what matters. Okay, so never reset, we can ignore. Self pin equals pin. Oh, we should look at here. So the digital in-out object is defined on a kind of common HAL level. And I'm just going to name this ESP32-S2. And if you've ever worked in shared bindings, you know that I probably nagged you about not accessing anything in here because it's meant to be only used by common HAL. Okay. So this is just holding on to a reference that we started with. We're going to need to support the get direction and well, we need to set direction, which must just be this switch to input. So let's scroll up. We're going to do this GPIO config. And so for those of you who don't do a lot of C, stars are pointers, which is basically the address of that structure. And then const is basically in GPIO config, it's saying, I'm not going to change this. I just need it passed in. So I'm just going to call it config because I'm exciting. And I'm not going to check the value of it either. And so this is straight up memory that's on the stack. And in order to pass a pointer, I have to take the reference of that, which is what the ampersand is. It basically changes it from the value itself to an address of the value. For those of you not watching the chat, actually you can't see the YouTube chat, so let me just read it off. Ivan and Diship, we were talking about whether it's slower or not. It's not measurable to have signals routed through the GPIO. Why then are the native pins preferred? So I/O mux is fixed routing of peripherals to specific pins, like when a pin has a few functions you choose from. GPIO matrix is a flexible mapping. Any pin can have any function. On the ESP32, the GPIO matrix is limited to 40 megahertz. So for high-speed SPI, you may want to use the I/O mux. No other case, I think. And Teshipu says, I see, that's why I thought it was slower. Right, so most stuff is less than 40 megahertz. But for signals that do need to go over 40 megahertz, they need to circumvent the GPIO matrix. But that's what gives a lot of flexibility. Okay, let's figure out what is in GPIO. Config T, which I can't click. So let's just see here. Driver include driver. I think that means that I just include GPIO. I might have to do some build stuff, which might mean it's going to take a little bit longer, but we got this. Gonna do it, gonna do it, gonna do it, gonna do it. Okay. Here's the file. We're looking for GPIO config T. What, really? There's one match. And it's not in here. Okay. To the command line. Figure out where it is. Where is it defined? It's used in a lot of places. We're looking for an H file. GPIO types. Include driver GPIO. Okay. I will do that. Oh, look at all those. Yes, here we go. This is what we want. I'm just going to copy it. Pin bit mask, mode, pull up, pull down, interrupt type. And I'm going to assume that I don't care. 64-bit pin mask, so it's probably just a shift. So if I had to guess, and this is the beauty of doing this on a stream, is I can just do 1 and then self pin number. Is that what I called it? So we're just changing 1. And then don't read these comments. I feel like I'm being rushed tonight. I don't know why. Like, I could take more time. Oh, lost my spot. Okay, interrupt type I'm not gonna do. I could do pulls. So, wait for them to go by. Those of you new to hardware, I think of pulls as default values. So it's a default value for a digital line, where the way that it actually works is that C99 initializers, if it gets a new member in the next version. Yeah, that's the equals this, right? Why does it save you though? Because I wouldn't set the other values. And are they semicolon separated? I think they might be comma. Mode. Pull mode. Okay, interesting. So input, output, open, drain. Open, drain. Everything you don't set gets set to 0. Yeah, I would hope the zeros are the default value. Okay, we're doing switch to input. So I'm going to use this. And then I'm going to say if pull. I'm off the beaten path, aren't I? Implementing inputs, but that's okay. I forget the names we call them. This will be config. Let's say if this is pull up, it is pull up enable equals. I could say true too, but true is 1, right? All right. We can delete this too because it should be working. And I just need to figure out what I'm comparing against, which is not here. It's in shared bindings, digitalio. It's like the name, the enums, yeah, that we use internally. Here. Wow. This person on YouTube literally has troll in their name. Like, come on. I must be getting more views today. I've got more trolls to go with it. And you can't see it anyway because you can see my Blinky. Okay, so we did input. And I'm just going to copy that for output. And it is interesting that the config doesn't take the value. So should we set value before we set it to output? Or maybe it's in the mode. But mode, we're going to want to say if drive mode equals, and it's right here, open drain. We could be explicit too. Then we're going to want to do output open drain. We don't actually support input and output at the same. All right. Everything's hunky-dory. We don't need polls, but we do need, we did drive mode. And then we could actually default it to regular output, which I assume is push pull. So for those of you who don't know, open drain is when your output basically only sets zeros. If it's a 1, then it just kind of detaches and lets whatever happen. And that's where pull-ups are really can be nice, like external ones, that they like set the value when nobody's setting it. Okay, now it makes more sense. Ivan says value defaults to 0, so you can set it with a separate function call. Okay, so can I set the value before I switch it to output? I can't tell you how nice it is having Ivan in the chat. Let's just pull it back up here. Set level. GPIO number. So that would just be self pin number. Christopher says, hello, Scott. Hi, Christopher. Thanks for joining in. Value. All right, that kind of looks okay. I need to set this to driver. And let's see if it compiles. Ivan confirms, yes, setting the value before calling config should be okay. Awesome. That means that we won't glitch the value kind of once we start setting it. So it's better to set the value before we turn it on to output. Okay, sock GPIO peripheral, no such directory. And that's because we have our own include pass, I think. So we want to do a find name, and then we'll just add the include path. So many things that we just need to improve. Oh, of course. So let's look at our makefile and make sure that we have that path included. IDF component sock. Okay, so we have the specific ones. We do not have. We have component sock include, but we do not have component sock include. So hopefully that'll fix it. It's all my fault for redoing all of that anyway. Generation says Adafruit, it's a development board or a controller like Arduino. This is, I would consider an Arduino or a development board, but I would consider Arduino a development board. Yeah, development boards are just boards that are unlocked and easy to load code onto to do what you want. Although Arduinos specifically are characterized by like the way that you can use them with Arduino software. Okay, so this error here isn't something. This is the undef thing that we can just fix quickly. Running out of time, but we'll get it going. We'll just go over time. Hopefully nobody else has a hard out. Components. I know it's probably late for you in Europe, so sorry for that. But I appreciate you being here. Hell. GPIO types. Line 51. And 157. Def. And then components driver. I do like this components layout. Driver include driver GPIO 25 def. Deshipu says it's only like 1 a.m. Mark's on New York time. Generation asks, are you building a circuit attached to it? Yes, I have just an LED that I haven't actually plugged in yet. And I should remind me to do that before I'm like, oh, it doesn't work. Do you remember what pin I used? I don't remember. Where did I put these wires? Okay, so I want to attach. Can you see this? You can see this. I'm going to peel these apart. I'm going to use black. That is a huge LED. Yes, it is. So black is going to be ground, and I'm actually going to do that on the pin. And the pin I used was, oh, I have compilation errors. You remember what pin number it was? It's like 36. I'll just plug it into 36. 36. And then I will plug the red. Can you see what I'm doing? Actually, I can switch to just the overhead so you can see, and I can see as well. So this is the development board with the ESP32-S2 on it. And then I'm going to plug in this side to 3.3 volts. So there's a small label here that says 3.3. So I'm going to plug the white female, and then that's going to be my high side. The LED is not on, but if I connect this black to ground, the LED turns on. Okay, you can see that. That's just me manually blinking. That doesn't count. But that's what we're going for. And if I plug it into 36, and go back to this. Yeah, this is just an LED I think I had from college. Just like one of those like random assortments of things. Okay, so I just got my pointers wrong. So let's go and fix that. Line 63. Here as well. So what this arrow does, for those of you who are new to C, is I was talking about pointers earlier where the value is actually an address. So the pointer, what it does is it takes that address and it like, it's called dereferencing, but it doesn't look for the value there. It goes to that address and then looks for the value. I guess is how I would describe it. Okay, did I get them all? Let's find out. And it looks like I called it set value, but I need to call it set level. Generation says, I got an ESP with Wi-Fi and Bluetooth. I'm trying to connect it somehow to Wireshark for packet capture. I don't know how to do that. This ESP does not have Bluetooth, although I hear a new version or a better version of it will. All right, looks like we're going. Our USB is now connected. That's good. Oh, and you know what? We loaded our code already. Looks like it crashed. Did it crash? Because we did an infinite loop. No, it's going. It's just not working. You know what we didn't do? You realize the thing we didn't implement? We didn't actually implement setting the value. Here. So let's do our dance and disconnect. And we know it starts up. So I'm actually going to turn the USB connection off. And I'm going to switch to just the overhead. And then I'm just going to rebuild and flash. If I'm in the right terminal. Hopefully we'll see some Blinky here. I'm going to grab my other water. Well, that's anticlimactic. I was expecting it to blink. And it's not. So, how do we debug this? We're over time, but we're rolling. Everybody good? Charles says, I think it should be on 34, not 36. Let's try that. Let's scooch this. Can you see? 2 over. Still nothing. And I confirmed I had it wired right. Marco agrees that it's 34, but I'm now plugged into 34 here. You can verify my work. 34. And the LED is not doing anything. So what do we do? One thing we could do is we can check our outputs. Yeah, David says, go for it. Nice to start the weekend with success. And Alvaro asks, is there a micro version of a library such as Django? Not that I know of. There is no micro version of Django. Although I wouldn't put it past people once we get some Wi-Fi going. And I don't actually know the Wi-Fi stuff that well. There might actually be. Okay, so let's add some logging. Yeah, Ivan said more printf debugging incoming. Yes, printf debugging for the win. I just need to figure out where I can snag the stuff for it. You know me too well. Copy these two things. And put it here. Check against 3.3 volts just to make sure it's not something other than the board. Okay. So, well, 3.3 volt, and then if I hit ground, so this is me setting ground, like attaching it to ground, it lights up. 34. And, okay. So we're going to printf our way out. And let's just see digital IO. More than fine. Yeah, I think I'm going to print out the pin number in here too. So the other thing I need to do is I'm going to snag the logging line. So construct %d and then pin number. And then let's just do a set value one as well. Pin number, and we'll do value as well. Will I check the pins with a multimeter? Perhaps. Maybe. I mean, I would use a multimeter if I was concerned about the connection between the module and the pin itself. But yeah, I don't think that's the problem. I mean, the software is untested. So it's probably that. All of these GPIO methods also return, they also return like an error. They could return an error, so I can do that as well. So let's just do a small iteration there for exactly this reason. Pin 104 is undeclared. I'm connecting ground to the IO pin. So I have VCC is this white cable. It's going to the red cable, which is going to the longer leg of the LED, and then down through this resistor that I don't know the value of. And then it's oh wait. Oh no, it is. It's in the right row. So black to black, which is to pin 34 as this is outputting. I did do one ULL bit number. Is not. I did just one. I could try that. That's right, because I'm over 32. Does it have to be caps? Let's try it. So for those of you who don't know, the ULL makes it a unsigned long value, which is 64 bits long instead of 32 bits long. Which 32 is probably the default. Which would make it to, hey, that was it. Ivan for the win. Thank you for that. So now what we can do is we can turn our USB back on. Hopefully it'll keep running. We can do our screen. And we're getting our ons offs. Man, Ivan's just on top of it. And then code.py. Here Whoa. How did we get this output on USB? That is weird. And we can do 0.1. And now we can do very weird. Oh, we reset. GPIO interrupt type error. We're not seeing that. Oh, you want to see my screen? Yes, thank you. This one. Yep, thank you. Sorry. It works. It doesn't work. It works. It doesn't work. So the thing I was weird about is that I'm actually getting some serial output on the USB. Thanks, everyone. I really appreciate all your help. And since we're over time, I think I'll wrap it up. But hopefully, yeah. So let's wrap up. Thank you, everybody, for hanging out with me for such a long time. We're over 2 hours now. You should be able to see the REPL. This is the REPL here. The serial output. Oh, Ivan says I need to zero initialize the GPIO config structure. Good point. Okay. Rabbit on Twitch asks, who are you talking to? Mostly talking to the YouTube chat. Donald asked, you said you have a Wi-Fi for your ESP32 chip on board. When will it be operational? Great question. This stream on Fridays at 2 p.m. Pacific is the time that you'll hear about that, along with a smattering of other stuff. Let me just run it down. Mondays at 11 a.m. Pacific, we have the CircuitPython community meeting where not just me, but everyone involved in CircuitPython gives a status update and hug reports to everyone. Everyone's welcome to attend. That happens on the Adafruit Discord, which is adafru.it/discord. Join us there all week, to get the absolute latest and greatest. That is also recorded and goes on the youtube.com/Adafruit site on there. You can see it's just like a screen of Discord for an hour and a half of everybody chatting. Wednesdays, we have show and tell at... what time is it Pacific? 5 o'clock Pacific, we have show and tell, and then at 6 o'clock we have Ask an Engineer. You'll hear some updates about CircuitPython there. And then after that, we have there's a show and tell on Thursdays at 2:30, which is great as well. I was on there yesterday, and then this stream is at 2 o'clock Pacific on Fridays, and and this will be kind of like status updates and working on ESP32 stuff. And then after that, we'll see. It seems like people really like these deep dives, so it might just be whatever I'm working on. Let me know. But yeah, this has been great. Thank you all. This has been a deep dive with Scott. I work on CircuitPython for Adafruit. We do this every Friday, as I said, at 2 p.m. Check it out. If you want to support Adafruit, go to adafruit.com. Find something on there. You can buy it from DigiKey, and they'll ship it out pretty quickly. Adafruit is, I think, also starting to ship orders that are made there as well, with no promise of it. Rabbit asks, what is your YouTube channel? It's youtube.com/Adafruit is the company I work for and what I'm streaming on. I also do have my own channel for myself, which is, I go by Tannewt, TANNEWT, on most stuff. But I've been streaming on Adafruit because they have an audience, which is awesome. So next steps for ESP32-S2. Somebody asked about Wi-Fi. That is not going to be my next step because that's a huge step. But we definitely want to get there. Good night, Mark. And I think for me, it's polishing up this pull request that I have so that we can get it checked in to mainline master. The work that I need to do there is... kitty. I'm sorry. I should have stopped when I had the cat. Good night, everyone. I'll talk with you next week.